So in this example, a software development team was having trouble meeting project deadlines, so they made two changes, breaking projects down into smaller jobs and also assigning each job a priority, either high, medium, or low. So let's say that we ask, what is the distribution of high, medium, and low priority jobs? So this is a question about one categorical variable. And it can be a little bit confusing because there are more than one category, of course. Any categorical variable is going to have more than one category. But really, we're only asking about one thing, priority, and then it has three categories, high, medium, and low. So we can look at either just the count in each category, or we can look at the percent of the total in each category. But either way, we're getting a sense of how they're using this system. One thing you might be concerned about if you're sort of in management here is that over half of the jobs are being labeled as high priority. So it's hard to say whether that's like the most effective way to use this system, but we can see that with the percentages here. So if we want to display the distribution of one categorical variable, we've got two options for that. One is that we can use a bar graph. So we've just got separate bars for each priority level. The height here is showing the count, but it could also be the percents. Notice this actually is different from a histogram. A histogram was for quantitative data, and because you had that continuous range along the bottom, the bars were all touching each other. Notice here that we have this blank space in between the bars, and that's generally how it's done for categorical data, for bar graphs. The other graph that we can use for categorical data is called a pie chart or a pie graph. So here we're looking at the same data. Obviously, we can see a little over half is high priority, and then we can see the split for the low and the medium. So I will say pie charts are a little bit more limited when you can use them. In particular, it's only appropriate to use a pie graph when the focus is on percents. Focus is on percents. So in other words, if you're looking at a pie graph, it must add up to 100%, right? You have to have all of the categories. The other thing is that you can't have anybody being counted twice or anything like that, anything that makes the percents not add up to 100. And even in a case like this is a case where we're looking at percents, it's reasonable to use a pie chart. I still actually tend to prefer a bar graph just because I think it's a little bit easier to read unless you're planning to like bust out a protractor and measure those angles. It's probably easier with a bar graph. The next question is, do high priority jobs tend to be finished faster? So here we have two variables and we want to look at the relationship between them. One is the number of days that it takes to complete each job. So that would be the response variable because that's really what the software development company cares about. And that's quantitative, right? It's being measured as the number of days. The other variable, what we're using to predict how long the job will take, is the priority level. So since we're using that to predict, this is the explanatory variable. And like we said before, priority is categorical. So to answer this graph using numerical summaries, we might calculate something like the mean or the median for each of the priority levels. If we want to make a graph, we need something that shows the distribution for each group. My favorite way to do this is with parallel box plots, which is what you see here. So you may notice that in this distribution, there are three really extreme values, and it turned out that these actually were a mistake. So there was some kind of problem with the system where basically they forgot to close out a job after it was finished, and so it ended up looking like it took way longer than it actually did. So that's why there's two different tables here. There's the table of the mean, median, standard deviation, and IQR with the outliers included. That's what's in the first one. And then the second table is what it looks like after removing the outliers. So take a second, look over the values in the table and the graph and see if you can answer these questions. Which numerical summaries are sensitive and resistant to outliers? And why do you think the mean is higher than the median for all three priority groups here? So sensitive to outliers just means that the value changes a lot when you take the outliers out. So we're only looking at the high category here. since that's where the outliers were. So we can see that the mean goes down a pretty good bit after the outliers were removed. So does the standard deviation. And so those values are sensitive to outliers. Whereas if we look at the median doesn't change at all, and the IQR changes very little. So those two measures are resistant to outliers. So notice for measures of center, mean, and median, the median is the one that is resistant to outliers. For measures of spread, the IQR is the one that's sensitive to outliers. So keeping that in mind, why is the mean higher than the median for all three of these priority groups? So notice that these are all skewed to the right, and they're actually so strongly skewed that it ends up treating a lot of those values as outliers on the high end. So if the mean is more sensitive to skew and outliers, those really long times are pulling the mean up a lot, right? Whereas the median is more resistant, it's not getting pulled up as much, so we end up with values where the mean is higher than the median. So basically, the reason that the mean is higher than the median is because the data is skewed to the right. If the data were skewed to the left, it would be the opposite. The mean would be getting pulled down, and the mean would be lower than the median. So because these values are so different, you have to make a choice of which one to use. And we probably want to think about like the typical amount of time it takes for a high, medium, or low priority job, not so influenced by those outliers. So we're going to use the median here. So we're going to use the median to describe typical job times. And this will be the choice that we generally make if the data are skewed. If the data are skewed and you want to describe the center, it would be better to use the median. If you want to describe the spread, it would be better to use the IQR. Okay, so we've removed the outliers, we've decided to use the median, and now we want to answer this question: do higher priority jobs tend to be finished faster? Well, it seems like the low priority jobs do tend to take the longest. Low priority jobs tend to take the longest, and that's not surprising. You would sort of expect that those get put off because they're not super important, and so those are going to be the highest, at least typically the highest. But there's sort of a surprise on this other end. The typical time for high priority jobs is actually longer than medium. Typical time for high priority jobs is longer than medium priority. So it's hard to say just from the data what's going on in this system. It could be that there's sort of a problem with the priorities, right? That people are doing jobs that are actually lower priority first, so that would be sort of a problem with the workflow. It could also be a problem with how people are categorizing the priority levels, right? We said that over half of the jobs were being categorized as high priority. Maybe that's not really appropriate, and maybe that's where this problem in the data comes from. So we can't exactly say just based on this data what needs to be done, but this is giving information to the software development team. The other thing that I wanted to point out here is sort of how many decisions had to be made before you could answer this question. So in MSIT 3000, we're not always going to ask you questions like calculate the median, right? Because if you think about like your real life job, you're not going to be told exactly which graphs to make and which calculations to do. That's just not realistic. So it's more likely that we would ask you a broader question, and then it would be up to you to figure out, okay, I graphed the data, it's skewed right, that means the median is more appropriate, and that's what I'm going to compare. So just sort of keep that in mind as you're preparing for the test, that it's about knowing what to do, not just how to do it.